Hello students, myself Numerical from LJIET Institute of Engineering and Technology. So in last session we discussed some numerical based on flywheeling punching press, and in today's session we have to discuss some numerical based on turning moment diagram. Clear? As you all know, there is three equations for the maximum fluctuation of energy. That is delta E is equal to I omega, omega 1 minus omega 2, delta E is equal to I omega square Cs, and delta E is equal to 2ECS. Based on this equation, we have to solve one more numerical based on the turning moment diagram. Okay, so in this numerical, there is one equation is given for the mean resisting torque line. Clear? So we have to use this equation for find out the value of delta E. The turning moment curve for engine is represented by the equation. So equation of the turning moment, that is T is equal to 20,000 plus 9500 sin 2 theta minus 5700 cos 2 theta Newton into meter. Now torque is given in the form of one equation. Clear? Where theta is the angle moved by the crank from inner dead center. If the resisting torque is constant, if resisting torque is constant, means value of the resisting torque is constant, and resisting torque value indicate the equation in the form of y-axis. Clear? And you have to find out the value of power developed by the engine. First of all, you have to power, and you all know what is the meaning of power: energy required per second or energy supplied per second. Second thing you have to calculate, that is moment of inertia of flywheel, and you all know what is moment of inertia, that is capital I, and equation of capital I, that is mk square. Clear? In kg into meter square. If total fluctuation of speed is not exceed 1% of mean speed, indirectly this value is given for the coefficient of fluctuation of speed, because the equation of the coefficient of fluctuation of speed, that is n1 minus n2 upon n. Clear? So the value of Cs, that is 1%, means 0.01. And third one, the angular acceleration of the flywheel when the crank has turned through 45 degree from inner dead center. Clear? When crank position at theta is equal to 45 degree, at that time we have to find out the value of angular acceleration. And what is angular acceleration? That is alpha. You have to calculate the value of alpha based on the equation of torque, that is torque is equal to I alpha. Clear? For find out the value of alpha, you have to calculate value of torque and moment of inertia. Clear? So you have to calculate three things in this example. First one power, second one moment of inertia, and third one angular acceleration. We have to calculate one by one. Clear? So first of all we have to list out the given data on this numerical, that is one equation for the turning moment, that is T is equal to 20,000 plus 9500 sin 2 theta minus 5700 cos 2 theta Newton into meter. Second, speed is given, that is 180 rpm. Third, based on speed you can calculate value of omega. Omega is equal to 2 pi n by 60. Clear? So 2 pi into 180 by 60 is equal to 18.85 radian per second. Since the total fluctuation of speed is 1% of mean speed, therefore coefficient of fluctuation of speed, that is Cs is equal to omega 1 minus omega 2 upon omega is equal to 1%. Now you can calculate 1% in simple form, that is 0.01. Now first of all, power developed by engine. We know that work done per revolution. Clear? Work done per revolution is equal to area under the curve. Now the turning moment diagram is torque versus crank angle. So you have to multiply the value of torque and crank angle, that is T into d theta. So you have to calculate, or you have to integrate the equation of torque at the duration 0 to 2 pi. So we know that the work done per revolution, that is area under the curve, is represented by integration 0 to 2 pi T into d theta. Clear? Now you have to put the value of T over here is equal to integrate 0 to 2 pi 20,000 plus 9500 sin 2 theta minus 5700 cos 2 theta. Now for this simplify this equation, you have to know that what is the integration of any constant value. Clear? suppose you have to integrate the value of any constant, suppose 1, then integration of 1, that is integration 1 dx, that means integration of 1, that is x. Clear? So in this equation we have one constant value, that is 20,000, and we have to integrate this equation with respect to angle d theta. So integration of 20,000, that is 20,000 theta, and you have to put the upper limit and lower limit. Again, one more term in this equation, that is sin 2 theta. So what is the integration of sin 2 theta? That is minus cos 2 theta divided by 2, because you have to put the value of differentiation of 2 theta in denominator of this value. So integration of sin 2 theta is equal to minus cos 2 theta by 2. You already learned these three. Clear? And what is the integration of cos 2 theta? That is sin 2 theta upon 2. Clear? So you have to put this value over here. So 20,000 theta minus 9500 cos 2 theta upon 2 minus 5700 sin 2 theta upon 2, and put the upper limit and lower limit 0 to 2 pi. Now first of all put the limit 2 pi and subtract and the lower limit. Clear? And you can calculate the value of that, that is 20,000 into 2 pi is equal to 40,005 Newton into meter. Clear? So work done per revolution, that is 40,000 pi. Clear? And unit of that, that is Newton into meter. Now mean resisting torque of engine. Now what is the work done? Work done is equal to area under the curve, or work done is equal to T mean into theta. You know this equation. So work done is equal to T mean into theta. So T mean is equal to work done upon theta. So work done upon 2 pi. So put the value of work done over here, that is 40,000 upon 2 pi. Clear? Work done per revolution, that is 40,000 pi upon 2 pi. So if you simplify this equation, then the value of T mean, that is 20,000 Newton into meter. This is the value of mean resisting torque. Clear? And mean resisting torque indicate the horizontal line. Equation of, suppose equation of the horizontal line, that is y is equal to 5. This is the equation for the horizontal line. In this case, instead of y-axis, we have to use a turning moment T. So equation of the horizontal line, that is T mean, is equal to 20,000 Newton into meter. We know that power developed by the engine, as you all know, what is the equation of power? Power is equal to 2 pi mt by 60. Clear? Based on this equation, you can calculate the power developed by the engine. Put the value over here. Clear? Power is equal to 2 pi nt by 60. One more equation of power, that is T into omega. Clear? Instead of omega, you can put 2 pi n by 60. Clear? And calculate the value of power, that is 377 kilowatt. Clear? So this is the value of the power. Now second thing, we have to calculate the moment of inertia of flywheel, that is capital I. For find out value of capital I, you have to calculate value of delta E, because equation of delta E, that is I omega square Cs. So if you have to calculate value of I, so you have to calculate, first you have to calculate value of delta E. Now we have one equation of the turning moment diagram in this sine wave, and second equation is T mean, mean resisting torque line, that is a straight line. So if we have to calculate value of theta at intersection point. Clear? In sine wave, there is one positive loop is there, one negative loop is there, but maximum work done we got in the positive loop. Clear? Because flywheel gains some power in only in positive loop. So you have to compare these two equations. One equation for the turning moment and second equation for the mean resisting torque line. And intersection point from this diagram, you see that is two intersection point, capital B and capital D. So we have to calculate the value of intersection point based on these two equations. So compare these two equations. T is equal to T mean. Clear? So 20,000 plus 9500 sin 2 theta minus 5700 cos 2 theta is equal to 20,000. Now if you simplify this equation, then 9500 sin 2 theta is equal to 5700 cos 2 theta. Now based on this equation, you have to calculate value of tan 2 theta. Clear? So tan 2 theta is equal to sin 2 theta upon cos 2 theta is equal to 5700 upon 9500 is equal to 0.6. Now using inverse, you can calculate value of the theta. So 2 theta is equal to 31 degree. So based on that, theta is equal to 15.5 degree. Now duration of cycle is 180 degree, 90 degree for the positive loop and 90 degree for the negative loop. Clear? So first intersection point at 15.5 degree. Now duration of cycle is 90 degree for the positive loop. So for the find out second intersection point, you have to add 90 degree in this value. Clear? So angle at theta B is equal to 15.5 degree, but value of angle at point D, that is 90 plus 15.5, that is 105.5. Clear? Now you have to calculate value of delta E and maximum fluctuation of energy generated at the positive loop. Clear? So maximum value of energy, that is delta E, only indicate the positive loop, and the duration of this positive loop is from theta B to theta D. Clear? So we have to calculate that area. Okay. Now maximum fluctuation of energy delta E is equal to integrate theta B to theta D, T minus T mean into d theta. Clear? We have to calculate energy only for the positive loop. Clear? So we have to subtract the area for the mean resisting torque line. Clear? Put the value of T and T mean over here and value of theta B and theta D over here. So 15.5 into 105.5 in bracket 20,000 plus 9500 sin 2 theta minus 5700 cos 2 theta minus 20,000 d theta. Now you have to integrate this equation, put the upper limit and lower limit and find out the value of delta E. Clear? So integrate 9500 sin 2 theta, that is 9500 cos 2 theta divided by 2, but in the negative. Clear? Minus 5700 sin 2 theta upon 2. Put the upper limit and lower limit and find the value of delta E, that is 11078 Newton into meter. So value of delta E, that is 11078 Newton into meter. Now based on that, you can calculate value of capital I. We know that maximum fluctuation of energy delta E is equal to I omega square Cs. Clear? So based on this, put the value of omega and Cs over here. We have to calculate value of I, put the value of omega 18.85 and put the value of Cs, that is 0.01. So in this equation there is only one unknown is there, that is capital I. Calculate the value of capital I, that is 3121 kg into meter square. Clear? This is the value of moment of inertia of the flywheel. Clear? I is equal to mk square and value of I, that is 3121 kg into meter square. Okay. Now we have to calculate angular acceleration of the flywheel at angle theta is equal to 45 degree. Clear? Alpha indicate angular acceleration of the flywheel. Theta indicate angle turned by the crank from inner dead center at 45 degree. So T axis is equal to T minus T mean, that indicate the, and we have to calculate this T axis at particular angle, that is 45 degree. Clear? So put the value of T and T mean over here and put the value of theta is equal to 45 degree in this equation, and you find out the equation for the T axis. Clear? Or value of the T axis, because we have to calculate angular acceleration at angle theta is equal to 45 degree. So we equation of the T is 20,000 plus 9500 sin 2 theta minus 5700 cos 2 theta minus 20,000, and put the value theta is equal to 45 degree in this equation, and this equation if you put the value of cos 45, now what is the value of sin 90? 1, and what is the value of cos 90? That is 0. So 5700 cos 2 theta is equal to 0 and 9500 sin 2 theta means 9500 sin 90, that is the value of 9500 Newton into meter. This is the value of T axis. Clear? Now we have to use the value of this torque for find out angular acceleration. Now you all know what is the equation of a torque, that is torque is equal to I alpha. Now we have to find out alpha based on this equation. Now we have value of torque and we have the value of I. So we also know that excess torque is equal to I alpha. Now I is equal value of I, that is 3121, alpha is one unknown term. Put the value of torque over here. So alpha is equal to 9500 upon 3121. So that is the value of 3.00 radian per second square. So value of alpha, that is 3.044 radian per second square. So in this numerical we calculate three values. First one, that is power. Second one, that is moment of inertia, and third one, that is angular acceleration at particular angle. Alpha is equal to 45 degree. Clear? So, and for solve this numerical, you have to use some basic fundamental of mathematics, some basic fundamental of integration and differentiation. Clear? You already learned all these three. Clear? So in next topic we will start one new chapter, that is gyroscope.